complex numbers leading on to loci in the organ diagram. Here we can see we have the complex number z1, which is equal to 3 plus 4i, and z2, which is equal to 5 plus 12i. Then we want to find the modulus, in other words the magnitude, of z1 minus z2. Well, underneath here we have the organ diagram. Remember, the horizontal being the real axis and the vertical being the imaginary axis. So z1, 3 across, 4 up if you're asked to plot it, and z2, 5 across and 12 up. So let's look at z1 minus z2. Well, z1 is 3 plus 4i minus z2, which is 5 plus 12i, which is equivalent to, well, 3 take away the 5 is minus 2, 4 take away 12 is minus 8, so we're minus 8i, and we're looking for the modulus of that. Remembering, the modulus is the magnitude. So the magnitude being the real part squared. We can almost ignore the negative there, because when we square it we get positive, plus the coefficient of the imaginary part squared, which gives us the square root of 68, which is the same as 2 root 17. Now, let's put that in the context of our diagram. So, let's think about that 2 and minus 8. Well, if we look at our diagram, to get from z1 up to z2, so the modulus is the length of that blue line. And to find that out, we can think we come across 2 and up 8, forming a right angle triangle of base 2 and height 8, giving us an hypotenuse of 2 root 17 using Pythagoras. 2. Given the complex number z1 is equal to 3 plus 2i, and that z, so an unknown complex number, satisfies the equation where the modulus, so in other words the difference between those 2 points, the distance between those 2 points, is equal to 3. We want to sketch the locus of z on an organ diagram. So what does this mean? Well, let's look at the point 3 plus 2i first of all. So 1, 2, 3, 1, 2. So at this point, z1 is here. Next, we want to think of all of the points which are at distance 3 from that. So we could think to the right, we could think above, we could think to the left, and we could think below. So in this case, the locus are all of the points which are a distance of 3 from z1. So it's not too big a leap to realise that this maps out to be a circle. And hopefully it's obvious from here that we have a circle of radius 3, and the centre has coordinates 3, 2. So if we look back up at z minus z1, the modulus of which is equal to 3, so z minus 3 plus 2i equals 3. So from this we can see the radius is 3, the x value of the centre 3 is the real part of z1, the y value of the centre is the imaginary part. Notice it must be written in this form. Question 3. We're given that z satisfies this equation, so the modulus of z minus this complex number equals 2. So this tells us the radius is going to be 2. However, we need to be careful here. We need to first of all look at this point, so z minus, and we need to have it in the form where we're subtracting the whole number. So to be clear here, z minus, okay, minus 4, and minus minus makes our positive 3 up here. So it needs to be in this form where we are one number minus the whole of the other number. What this tells us then is the centre is 4 minus 3 and the radius is 2. So let's plot that. So 4 minus 3 gives us this point here. So this is our point 4 minus 3. So 4, labelling our axes, this is the imaginary, this is the real. And then the next part, thinking a radius of 2, so we can work our way around, helping us sketch by plotting almost the points north, south, east and west, and then drawing a nice circle around it, and we have the locus of the point Z. So the point Z really represents any point on this circle, because at any point it is a distance of 2 from the point Z1.